The bearing from Atlanta to Macon is 20 degrees east of south, and the bearing from Macon to Augusta is 63 degrees east of north. An automobile traveling at 62 miles per hour needs 1 1/4 hours to go from Atlanta to Macon and 1 3/4 hours to go from Macon to Augusta. Find the distance from Atlanta to Augusta. Round to the nearest mile as needed. All right, so this is a very similar problem to example 8. So I just want you to get extra practice with it. Do notice though that the bearing is described differently, okay? So we don't have just a single angle, we have direction included, okay? All right, so these are 3 cities in Georgia that we are dealing with. We are going to need a starting point. Okay, so I'm just going to read through the first sentence again. It says the bearing from Atlanta to Macon is 20 degrees east of south. Okay, so I'm going to start by drawing Atlanta and Macon. All right, so here we go. I'm going to put a point. Okay, we're going to say that this is Atlanta. So I'll label that here. And then we're given a bearing, okay, to get to Macon. Okay, so I'm going to go in and put my little north, south, east, and west cross. Okay, so this time it's going to be different, like I said, because we have those directions on there. Okay, so we need to consider all of the directions here, not just north. Okay, so here's our east-west line, and then here's our north-south line. All right, so this is what it's going to look like. Okay, so north, south, west, east. Okay, so basically to get to Macon, okay, Macon is 27 degrees east of south from here. Okay, so here we go. When you draw here, okay, we have to align ourselves with due south. And then we go 27 degrees towards the east. Okay, so here we go. When we draw this in, we have to align with due south. And then we're going to rotate 27 degrees towards the east. Okay, so we go in this direction. Okay, so we're going to end up right here. Okay, I am just eyeballing this. Okay, I probably made the angle a little too big, but this is going to be 27 degrees. Okay, it's 20 degrees in the east direction, okay, moving from due south. Okay, so this is going to be Macon. Okay, we do have some information about the distance between Atlanta and Macon in the way of speed, the speed that an automobile is traveling and how long it takes to go from Atlanta to Macon. So let's focus in on that. It says an automobile traveling at 62 miles per hour needs 1 1/4 hour to go from Atlanta to Macon. So what we have here is this car traveling 62 miles per hour, okay, and needs 1 1/4 hours. Okay, that's 1.25 hours, okay, to go from Atlanta to Macon. So if you set it up this way, you see that the hours are going to cancel. So if we go to our calculator, this is going to be 62 times 1.25. Okay, and that's going to be 77.5. Okay, so since the hours canceled out here, what's left is miles. Okay, so this is going to be 77.5 miles. Okay, this is the distance between Atlanta and Macon. Okay, so in our picture, we can come down here. That black line segment, we can label it as 77.5 miles. Okay, all right, continuing on because there is a third city involved. Okay, so now we're told about the bearing from Macon to Augusta. Okay, so I'm going to highlight that information. The bearing from Macon to Augusta is 63 degrees east of north. Okay, so be careful here. The bearing is from Macon to Augusta. So that means you're starting at Macon. Okay, you're going to have to draw your cross at Macon. Okay, and let me put it in here. I'm going to put it in a different color so you can see it. Okay, so it's going to look like this. And again, the bearing is expressed not only with the angle, but with the direction. Okay, so here is north, south, west, east. Okay, so when I do this, okay, the bearing is from Macon to Augusta. We have to rotate 63 degrees east of north. Okay, so to interpret that, what you're going to do here is you're going to align yourself with due north, and you're going to rotate towards the east. So you're going this way, not this way. Okay, so align yourself with due north and rotate 63 degrees. You're just going to have to eyeball it. Okay, and I'm not sure about the distance, so I'm just going to leave it off right here. Okay, so this is going to be Augusta. Okay, we know that this angle right here, this angle is 63 degrees. Okay, all right, so now we're given information about the distance from Macon to Augusta, again through the automobile. Okay, so if we look at that information, we are told that an automobile traveling at 62 miles per hour needs 1 3/4 hours to go from Macon to Augusta. So we're going to do the same kind of thing. The speed is the same here, 62 miles per hour. The car is traveling this time for 1.75 hours. Okay, so again, you'll have the hours cancel. And then if you multiply these two numbers, that will give you a mileage. Okay, so 62 times 1.75 is going to give you 108.5 miles. And this is going to be the distance between Macon and Augusta. Okay, so if we come down here, we can label this distance, okay, as 108.5 miles. Okay, what we want, if we go back to the original question, we want to find the distance from Atlanta to Augusta. Okay, that is what we want. Okay, so in the picture, what we're trying to find here, and I'll use a different color so it stands out, we are trying to find this purple distance, okay, the distance from Atlanta to Augusta. Okay, this is what we want. How long is this line segment? Okay, all right, so I'll put that here. That's what we're looking for. Okay, all right. So we need to start working with what we have. It's a very congested picture, as all of these have been. We do have a triangle that has been formed. Okay, we know two sides of the triangle, and we want the third side. Okay, so as the other questions have been going in this section, you do not know for a fact that this is a right triangle. You have to prove it before you can use the Pythagorean theorem. Okay, so when you look at this, let's focus in on this angle. If you can see where my cursor is, let's focus in on this angle. You can see that this particular angle is comprised of a 63-degree angle and this little angle right here. Okay, so if you add those two angles up, we're curious to see what we're going to get. Is that indeed a 90-degree angle? Okay, so we're going to have to do some work here. So let's do some more drawing on our picture here. Okay, so let me take these off. I'm going to rearrange them. So let's say here's my south, here is my west. Okay, if I extend these lines, we will get a right triangle. Okay, so if I draw my west line a little, if I extend it a little more, I should say. Okay, So if we extend this a little more, and then we extend the south line, okay, to like right here. Okay, it's not matching up exactly. There we go. Okay, so it's going to look something like this. This is going to form a right angle. Okay, it's going to look like this. We know if we look at this particular triangle, okay, we know one of the angles in the triangle already. Okay, one of them is 27 degrees. The second angle is a 90-degree angle. And so we can calculate that third angle. Okay, so if I know there's 180 degrees in any triangle. Okay, so if I take 180 degrees and I subtract out the 90-degree angle, and then I subtract out the 27-degree angle, that should leave me with 63 degrees. Okay, so you can check 180 minus 90 minus 27 is going to give me 63. Okay, so this is a 63-degree angle right here. Okay, that's this angle. Okay, well, what do we do from here? Well, I can now focus on the bearing at Macon. Okay, see my red north-south line and my east-west line. Okay, those two guys form a right angle. Okay, so right here, let me find my black pen here. This is going to be a right angle. Okay, just by the nature of north, south, west, and east. So I know this 90-degree angle is comprised of a 63-degree angle and something else, which is going to be right here, this little tiny thing. Okay, so I can figure out what it is if I just do 90 degrees minus 63 degrees. Okay, that's going to be 27 degrees. So this teeny tiny angle right here is 27 degrees. Okay, and now what I can look at, okay, that ice blue angle that I'm trying to get, which is right here. Okay, if you can see where my cursor is, this little guy, I can figure it out now, because if I look at the red west-east line on Macon, it forms a straight angle 180 degrees, and we know all the angles that make it up except for that ice blue angle. So we can take 180, going from left to right, we're going to subtract the 63 degrees, and then we don't know what the ice blue angle is. The other blue angle is another 63 degrees, take it out, and then the last angle in the straight angle is 27 degrees. Okay, so if we go to our calculator and figure this out, we are going to get that that ice blue angle measures 27 degrees. Okay, so that is what this guy is going to measure. Okay, so let me write that on here. This little ice blue angle is 27 degrees. Okay, so now if we look at the overall purple triangle, okay, and I probably should color it in. Let's color it in some color so we can see it. I'll do like a really light blue on it. So well, that doesn't really work because then the blue pen will overwrite it. Let's see here. Let's maybe gray. Let me do this. Here, we'll do this. We'll do really light yellow. Okay, this particular right triangle right here, this guy, okay, this angle right here, okay, we have the ice blue angle and we have the regular blue angle. Okay, the ice blue angle is 27 degrees, and then the regular blue angle is 63 degrees. If you add those guys, you're getting a 90-degree angle here in the corner. Okay, so this is a 90 degree angle right here. Okay, so that pale yellow triangle is a right triangle. Okay, we know one of the sides, the side from Atlanta to Macon, is 77.5 miles long. We know the length from Macon to Augusta is 108.5 miles long. We need the hypotenuse, that purple line that is directly across from the right angle. Okay, since we have now confirmed that this is a right triangle, we can apply the Pythagorean theorem. Okay, so c squared is equal to a squared plus b squared, and we know we're looking for c squared, so we'll pop in the other two numbers. So we'll get 77.5 squared plus 108.5 squared, and then that will give us a calculation for c squared. So let's go plug that into the calculator. So 77.5 squared plus 108.5 squared. So here's the number for C squared. So 17,778.5. Okay, I don't think I wrote enough sevens. Let me fix that. Okay, so here we go. And then if we want C, that's going to be the square root of this number, has to be positive. Okay, so let's go to our calculator and do this. The square root of this number is going to be this number, okay, which I will go ahead and write down the full decimal expansion. So C is going to be it's going to be equal to 133.60416. Okay, so we can go ahead and round it. Okay, we are asked to round to the nearest mile. Okay, so we have 133. There is a 3 after the decimal point, and so the 133 will stay. Okay, so the distance that we're looking for is approximately 133 miles. Okay, that is the distance, the approximate distance from Atlanta to Augusta.